could the science in Project Hail Mary actually work in the real universe? Because this story is packed with real science. And I got to sit down with the star of the film, Ryan Gosling.
Well, this isn't intimidating at all, talking to a real astrophysicist.
And author Andy Weir to chat about how the science in Project Hail Mary, one of the most scientifically ambitious sci-fi stories ever, was translated from the book to the big screen.
It was very important to Andy that the fake space math be real.
It's got alien life, interstellar travel, relativity, astrophysics, molecular biology, and more. I'm Dr Becky, I'm an astrophysicist at the University of Oxford, and I'm gonna break down the science behind Project Hail Mary, separating the real physics from where the story naturally has to lean into the fiction side of sci-fi. So we're gonna cover what could make the sun dim, the science behind astrophage, relativity and time dilation, what we know about the real stars tau-ceti and 40 Eridani and their planets, and finally the science of alien life, but not as we know it. Plus, I also got to sit down with the directors of the film, Phil Lord and Christopher Miller.
I feel like I'm about to get busted.
No, not about that. To chat about how you visually communicate difficult concepts like relativity on screen. There will be mild spoilers ahead, but I promise I won't spoil any major plot points, nothing beyond what's already been revealed in the trailer. So before we get to aliens and panspermia, we need to start with the astrophysics problem that drives this entire story.
I need you to come with us. The sun is dying.
In Project Hail Mary, scientists discovered that the sun is slowly dimming, which could lead to a drop in the average temperature on Earth, leading to a new ice age and global mass extinctions and the breakdown of society itself.
Everything on this planet will go extinct, including us.
So could that actually happen? What could make the sun dim? Well, firstly, stars change their brightness all the time, right? Our sun isn't giving out a constant amount of light. It goes through an 11-year cycle where the brightness changes about 0.1%. That leads to a change in Earth's average temperature globally of about 0.1 degrees Celsius. A tiny amount that pales in comparison to the 1.5 degrees Celsius average rise in temperatures due to man-made global warming. But you would only need a 1% drop in the sun's brightness to plunge Earth into a new ice age. And a 10% drop in the sun's brightness to likely wipe out all life on Earth, at least life on the surface anyway, in the famous words of Ian Malcolm.
I'm simply saying that life, finds a way.
There is nothing about the sun, though, that suggests that is ever going to happen, at least until it starts to run out of fuel in about 5 billion years' time. So instead, like in the story of Project Hail Mary, could there be something that could block or absorb the sun's light before it reaches Earth? We've actually seen stars dim dramatically before, like Tabby's star, also known as the WTF star. Have you ever heard of the WTF star?
No.
It's shown erratic and bizarre dips in its brightness, up to a massive 22% drop in the light reaching us here on Earth. And I feel like it could be the real Project Hail Mary kind of star.
It's dimming?
It's dimming.
Because of...
It's still a bit of a mystery to us, to be honest, what's actually caused this dimming. There's lots of ideas raised, from something disrupting the fusion going on inside the star, to an alien megastructure being built around the star, to the most likely hypothesis that there is just a lot of clumpy dust orbiting the star blocking its light. So the amount of dimming happening to the sun and other stars in Project Hail Mary is not unheard of. It's just very unlikely. But of course, the dimming in Project Hail Mary is not due to dust in the story. It's caused by a microscopic life form called astrophage that actually blocks and feeds on some of the sun's light, kind of like a space algae bloom, which sounds weird, but if you think about it, life on Earth already does something vaguely similar. Which brings me to the science behind the fictional astrophage. Because, like how plants use photosynthesis to convert sunlight into chemical energy to power life, astrophage in Project Hail Mary takes that idea to the extreme, doing an incredibly efficient conversion from the energy it absorbs from the sun to then releasing that in order to be able to travel through space at great distances. But is that realistic? Like, how much energy can life on Earth with normal cellular biology actually store? We're powered by glucose, for example. sugars, right? And the energy from that comes from the chemical bonds within the molecule itself. And it's when the molecule is broken down, when glucose is broken down into something else, that energy is released and used to power life. For glucose, it's around 17 kilojoules per gram. That's around about 4 calories per gram. But what astrophage is doing is taking light from the sun, storing it as mass, and then releasing it as pure energy again. What's known as mass energy equivalence, or E equals mc squared, Einstein's most famous equation. It tells us essentially that mass and energy are the same thing. Mass is just like stored up energy. And so this equation allows us to work out, okay, if I take a gram of mass of something, how much energy will I get out of it? To work that out, you have to multiply it by the speed of light squared, which is 300,000 kilometers a second. It's a huge number before you've even squared it. So there is an immense amount of energy stored in mass. It's what powers the sun and nuclear bombs. And what it means is that 1 gram of astrophage stores 89 billion kilojoules per gram of energy. Now, in real biology, we've never seen anything like that. So although this part of the story, has its foundations in real physics, this really does sit very firmly in the science fiction side of things. Especially since in the book, the astrophage uses real particles called neutrinos to store that energy as mass, a point which Andy Weir concedes is where the physics really starts to break down.
You have to dig down to the quantum level to find where I have my made-up physics, so I'm proud of that.
I think I know what you're talking about as well, right? Neutrinos.
The super cross-sectionality of... I came up with that term, and I like it.
I like it too. It's a good one.
Super cross-sectionality. And it is...
Watch people start using it in the literature now.
Yeah, I watch, yeah. It's nothing can quantum tunnel through astrophage cell membrane. Because I said so.
Yeah.
But it's this plot device of astrophage's immense energy storage that allows it to be able to be used as a fuel for interstellar travel. Which brings me to relativity and time dilation in the story. The mission in Project Hail Mary sees Ryan Gosling's character traveling to the nearby star tau-ceti, which is 12 light years away from Earth, meaning it takes light traveling at the universe's speed limit of the fastest speed there is, about 12 years to get from tau-ceti to us here on Earth.
It's 11.9 light years away. You can't just build an interstellar ship.
Oh yeah, we can.
With our current spacecraft and propulsion technology, reaching a star that far away would take tens of thousands of years. But with astrophage, you have enough energy stored to just keep on accelerating your spacecraft up closer and closer to the speed of light, which means that any journey should take around about 12 years to get to tau-ceti. Right? Except if you're paying attention while you're watching the film, you'll hear how the ship's computer says that the journey takes just over 4 years. So how does that work in a universe where nothing can go faster than the speed of light? The answer is relativity and time dilation.
Yeah.
Would you be able to explain relativity and time dilation to me
Not
now?
to you. No, why would I do that? Can you explain it? I just want everyone in the room to understand. Because, we're in the know, obviously.
Yeah.
So, how would you explain it?
Well, how would you explain it?
Probably the same way you would. Exactly the same.
Mm-hmm.
Yeah.
That space and time are relative, and it depends how fast you're traveling.
Yeah. Exactly.
Yeah.
Oh, my God. Why melt?
We're on the same wavelength.
Are we twinning right now?
When you travel at faster and faster speeds, time actually passes more slowly for you than someone on Earth. This is a real effect predicted by Einstein's theories of special and general relativity that we have since been able to prove using very precise atomic clocks, one left on Earth and one put on a plane and flown around the world. We've shown that the time on the two clocks was different once they were brought back together. And if we didn't take into account these effects from relativity, then GPS and satellites orbiting Earth just wouldn't work. Now, there's a simple calculation to work out how much time dilation happens. This is called a Lorentz transformation. And it all depends on this, the ratio of your speed compared to the speed of light. So if the ship Hail Mary experiences 4 years on the journey from Earth to tau-ceti rather than 12, we can work out that that ship had to be travelling at about 94% the speed of light. Except that's a massive oversimplification. The ship is also accelerating to get to tau-ceti, which also provides artificial gravity on the ship, and it's why you'll see Ryan Gosling's character walking around normally at the start of the film. But acceleration means that your speed, v in this equation, is always changing, which messes up how much time dilation you experience. Basically, it means that your calculations are nowhere near this simple anymore, unfortunately. And I couldn't help myself from asking the really nerdy question to Andy Weir of whether he'd considered this.
Were you doing simple Lorentz like transformations, or were you doing like full second order GR acceleration calculations to throw in there as well?
Full general relativity. Relativistic rocket equations. I did not derive them. I found them online and then used them.
Nice. Yeah.
I have spreadsheets upon spreadsheets, just more spreadsheets than you can shake a stick at. I love it. And that's my favorite part, by the way. The math and science of it is all. I'm going to do a screen share here. So this is just the spreadsheet for things related to Hail Mary, fuel insulation, fuel volume, how the centrifuge works, how the engines work, how spin drives work, and so on. It just keeps going on. And that's just one page. Here's a bunch of stuff about astrophage, like, it's biological mass, it's propellant rate. Oops, I did something bad there. Okay, yeah. And so on. These are constants, and that just keeps going on.
It was very important to Andy that the fake space math be real.
Yeah, and to me, and to all of my colleagues.
Yes,
We were very
and he was like,
pleased with
it has to be real. And I was like, wait, the fake math has to be real? And he was like, yes. Yeah. That was impossible for me to memorize.
Okay.
The equations, especially on the whiteboard scenes. So I had an earwig in my ear, and I would have them just calling out the formulas so I could do it accurately for Andy.
So this is one area of the physics that Project Hail Mary gets spot on, but it's a really technical idea to communicate to an audience watching a film who might not be familiar with it. So this question of how you translate scientific ideas like this to the big screen was something that I asked directors Phil Lord and Christopher Miller about.
Throughout it was about how do you get these complicated ideas about like time dilation or centrifugal gravity or other things like that across to the public who doesn't want a lecture hall. They want to be entertained.
And how do you get it across in an entertaining way, in a cinematic way?
Exactly.
And how much can we do without dialogue?
What informed those decisions on if you verbally or visually communicate an idea?
Ideally, it's visual, and that you use as few words as possible.
We basically record a bunch of dialogue, but then try not to use it. We try and tell the story visually, and then what we do is we show audiences, and if people are confused, we give just enough so that it's digestible, so that they're not confused or frustrated. But then also try to use humor to make the medicine go down.
We had a lot of consultants on set. We had specific consultants for all of the chemistry experiments, right? All the lab work. We also had Andy Weir, who had, created all of this stuff in his novel. So he was often on set, and if he wasn't, he was on speed dial.
He makes a living at making complicated science digestible.
Yeah. We had a physicist on the visual effects team. It was also very helpful, especially in post. And I'd say the main challenge was to make sure that whatever dialogue we had, it felt like something Ryan would say, and not just simply something that that the plot is asking him to describe, right? So that was a big trick, and something that Ryan was very keen on perfecting.
So yes, translating relativistic physics to the big screen is very difficult, but all the action in the film is happening around the real stars tau-ceti and 40 Eridani. So what do we actually know about these stars and their possible planets? Tau-ceti is actually one of the closest sun-like stars to Earth. It's about 94% of the sun's mass and about half as bright. Now in 2013, Tuomi and collaborators claimed to have found evidence for 5 planets in orbit around Tau-ceti by looking at the star's wobble. Planets don't just orbit stationary stars. The planets pull a little bit on the stars as well, causing the star to wobble. And the bigger the planet, the bigger the wobble. Tau-ceti appears to have a very complicated wobble, which Tuomi and collaborators claimed was the combination of the pull of 5 planets, Tau-ceti B, C, D, E, and F. But is that actually the case?
It was believed to exist when I wrote the book. It has since been disproven. It aligns almost perfectly with like stellar flare activity. And so they're like, yeah, we thought there was a planet there, but there isn't.
Sadly, a study from Figueira in 2025 couldn't find evidence for any planets around Tau-ceti, and instead claimed their data could just be explained by the star pulsing in brightness. Sadly, the same is also true for 40 Eridani, another real star, just a bit smaller and cooler than the Sun, that is 16.8 light years from Earth. It too was thought to have a planet in its habitable zone back in 2018. An idea that people got very excited about because apparently in the Star Trek universe, the planet Vulcan is also supposed to be orbiting 40 Eridani. But this research paper from Burroughs and collaborators in 2024 revealed that the variation seen was actually, again, just due to the star and probably not the presence of a planet. Plus, it's worth noting that any planet in orbit around 40 Eridani would be impacted by the 2 dwarf stars also orbiting 40 Eridani in what's known as a tertiary system of stars. And these white dwarfs give off flares of X-ray light, X-ray radiation that would most likely wipe out any burgeoning life on planets around 40 Eridani. Rocky! So while motivated by real science when the story was written, unfortunately it's now looking like Adrian and Erid don't exist. So what about the final element on my list? The science behind alien life, but not as we know it. One of the central ideas in Project Hail Mary is that life can spread between star systems. A real scientific idea known as panspermia that raises the possibility that maybe microbial life can travel between stars on asteroids or comets or even tiny dust grains to spawn life on other planets, giving all life a common origin. That, I promise you, is not as crazy as it sounds. We already know, for example, that you can get material transported between planets in the solar system. We have meteorites on Earth that we know originated on Mars, chunks of rock from Mars. And we know that some asteroids, chunks of rock, get ejected from newly formed solar systems, and have even had asteroids passing through the solar system after being ejected from other star systems, what's known as interstellar objects. Plus, we know that life can survive in extremely hostile environments, from deep ocean pressures and extreme temperatures on Earth, but also intense radiation and the vacuum of space. The Photon M3 mission showed that tardigrades, a microscopic organism, were able to survive exposure to space's vacuum for 10 days, and once brought back to Earth, were still able to reproduce. So this idea of panspermia is becoming more popular, with astrobiologists actively studying whether life could survive those conditions for long periods of time. So the idea of astrophage traveling across interstellar distances to infect other stars isn't a proven idea by any stretch, but it is still rooted in established scientific hypothesis. But one of the big science plot points of Project Hail Mary is whether life needs water to exist, with Ryan Gosling's character leaving research and academia because he was shunned for saying that it didn't. This is completely sensationalized for both the book and the film. The idea that life could be different here on Earth and not need water to exist is an active area of research, from the astrobiology to the chemistry of what's powering it, and even what we'd look for with our telescopes to find evidence for it. I've made a whole video on the search for life, but not as we know it. If you want to check that out, I'll link it down below. Do you think aliens exist? I'm not talking like UFOs and Area 51 conspiracy theories. I mean like life out there in the universe.
It seems like if we're here, it makes sense that they're there, wherever that is. And I like that we're in a time in history where it feels like the conversation has shifted away from is there or isn't there, and it has become more about like, well, when will we find
where
out?
And when.
And where.
Yeah.
I think that's really, and I think that's why it's a perfect time for this movie, because this is like, I think a bit, I mean, you tell me, but it seems like a more credible approach to what that might be like, you know?
So how realistic is Project Hail Mary? Well, in some areas, like the time dilation and the artificial gravity, the physics is solid. In others, like the astrophage, the story pushes far beyond what we know about cell biology and energy storage into the realms of science fiction. But that is exactly what good science fiction does. It starts with the real science and then asks, what if? You can see Project Hail Mary first on the 14th and 15th of March and in cinemas everywhere from the 19th of March. I saw it at the worldwide premiere in London and it was fantastic. The visuals, the cinematography, I laughed, I cried, it was brilliant. I hope you enjoy it as much as I did. Just to sort of prepare.
It's a pipette.
One of the little squeezy things.
The squeezy thing.
Yeah.
I knew that. I just didn't think everyone else knew. Right? I heard him go like, what? And I was like...
Or a microscope,
I didn't want to alienate the room.
Mm-hmm. Yeah, that's fair. Water bears. Moss piglets. What a cute name is a moss piglet. And then asks, what if? Belly grumbled while I did that. It was a very dramatic moment and my belly was just like, feed me.